do this? Too much? Yeah. All right. Okay. In our last video, you saw the why behind significant figures. And right now, if you can't tell the difference between a significant figure and a polyatomic ion, you should definitely go back and watch that video. Otherwise, if you do know the difference between those two things, stay here with me. I'm Johanna Brown. I'm a real live chemistry teacher, and today we're going to talk about the next step of significant figures, and that's doing math with them. Because there's nothing like having your chemistry teacher teach you something that might be slightly confusing and then saying you need to do math with it and get a right answer. So let's figure this out. So significant figures are all about taking measurements. So let's say that you have two measurements. One with a super precise caliper, you have 5 significant figures. You're reporting that last uncertain digit as a significant figure. Fantastic job. And then you pick up a junky ruler off the ground. You only have 2 significant figures. This 4 right here is your uncertain digit, and you need to add those and then report those as a scientifically accurate number. So what we need to do is make sure that we track where the uncertainty travels in the number to figure out how to write an answer that has the correct number of sig figs. So let's see how this works. 1 plus 2, we got 3, I hope, right? Okay, 0 plus 4, and we have an uncertain 4, so we are going to get an uncertain number here in our answer, okay? Then 1 plus nothing is 1, 0 plus nothing is 0, 4 plus nothing is 4. Okay, so in all numbers that you report as significant, you can only report all of the certain digits, which in our case right now is the 3, followed by 1 and only 1 uncertain number. So that's our 4, right? Because if we have uncertainty here, these numbers don't really matter. We can't be certain about them, and we can't report them. So our answer in this case would be 3.4. All right. What's actually nice about these is we have rules for sig figs. So you don't need to color code like I did just to do it on a test. And the first rule of sig figs is that you don't talk about, no? Is that, okay. The first rule of significant figures is that when you're adding or subtracting, you can only report numbers as far as the first uncertain digit. I even like to just draw a line where that uncertainty begins, so that then I know in my answer, I don't even have to think about it on the test. I know exactly where to stop and where to round. So that's how I like to do it. Let's make sure that we understand this by doing a subtraction problem right here. So you are not going to have nice color-coded numbers, I'm assuming, so you're first going to have to figure out what is uncertain and how many sig figs are even in these numbers. So 110, how many sig figs here? Hopefully you got 2, good job, all right. And then which one of these is the uncertain digit? Well, it's this one right here, okay? Because remember, zeros without a decimal point to the right don't count. So 110, here's the uncertainty. 2.54, how many sig figs? 3, exactly, with this 4 being our uncertain digit. Okay, so let's subtract these and see what we get. We're gonna get 100, and then we're going to get 0, and that should be uncertain because that's going to track through. 7.4 and 6. Okay, so where does our uncertainty start? Right here at the 0. I could have just drawn a line to track that. So when you write your answer, it's going to be 1, and then what's our next number? Well, it looks like a 0. Always, where you're going to cut it off, look to the right and see if you should round. This is a 7, so we should round. Here's our uncertain number right there, and then we're going to have a 0 at the end because we have to stop reporting. And you might think, that was super arbitrary. We started with 110, we subtracted 2.54. But the important thing is, you need to understand that because this 1 was uncertain, we don't know any of these further numbers. So this won't even matter for when we're reporting our number, all right? Let's look at how multiplication and division work. I actually think that these rules are a little more straightforward for multiplication and division, and it's the same basic idea, just things work out a little bit differently because of where that uncertainty goes into the number. So again, let's see, we've got 3 sig figs here. That 4 is uncertain. 2 sig figs here, with that 2 being uncertain. Let's do the math and track it. 2 times 104, we're going to get a completely uncertain number because that 2 is now affecting all of these numbers, right? So 208, and then we're going to multiply 10 times 104 for 1,040. So add those together to get your final answer, 1,248. Same thing, when you report your answer, you can only have one uncertain digit. So our answer is going to be 1,200 due to rounding. So the rules for multiplication and division are that you can write as many significant digits as your measurement with the fewest number has. So this measurement has 3, this measurement has 2. I can only report 2 in my answer. Let's try this with division. 1,001 divided by 3.39. I actually did this one already on my calculator. So here's what I got. 295.28023598. If you do this, there's no faster way to annoy your chemistry teacher. These numbers don't matter. It's a waste of your time to write all this out. So let's see how many sig figs we should actually report in our answer. This has 4, this has 3, so we should only report 3. So I'm getting 295. Let's check the number to the right. That's a 2, so it stays at 295. All right. We're almost done with the math of significant figures. Stick around, another video will pop up where we combine all of these operations and we're able to track significant figures through multiplication, division, addition, and subtraction all in one problem. So thank you so much for watching. Don't forget to subscribe and I'll see you around. Cut!
That's my line, I'm the director.